Good morning, children.
Good morning, sir.
Good morning. We are discussing the chapter Fundamental Concepts of Algebra. So, in the previous class, we have already discussed about different terms related to this particular chapter, and I think we have discussed about what is a constant, what is a variable, what is called an algebraic expression, then the terms of the algebraic expression. We have discussed about the various types of algebraic expressions, for example, the monomial, what is called binomial, trinomial, multinomial. Then we have discussed about what is called the factor, that is the factors of a term, what is called the constant term. Then we have discussed about the coefficients, and we have talked or discussed about what are called the like terms and the unlike terms. And finally, we have the last thing that we discussed in the previous class is what is a polynomial. So now today we will discuss further, we will extend our concept on this particular chapter. So today we start with degree of a polynomial. Degree of a polynomial in one variable. What is called the degree of a polynomial in one variable, right? So now write down the highest power of the variable in a polynomial of one variable is called the degree of the polynomial. So according to the definition, the highest power of the variable in a polynomial of one variable is called the degree of the polynomial. So let us understand this with an example. If you write 3x plus 7x square plus 3x cube minus 2. Now this is a polynomial in only one variable, and that is x. Okay. So what is the highest power of the variable? The variable is x, and the highest power of the variable you can see clearly is 3. X is here power 1, x is power 2, x power 3, and here x power 0. So in that case we can very clearly see that the highest power is 3. So degree of this polynomial, degree is equals to 3. And what will be the reason for the degree being 3? That it is the highest power of x. It is the highest power of the variable x. Okay, so any polynomial you get in one variable, the highest power of that variable will be called the degree of the polynomial. We can take another example. 3y minus 4y square plus 3y to the power 5. This is also a polynomial in one variable, and the variable is y. So the highest power we can see is 5. So what is the degree of this polynomial? So degree is equals to 5. So this is how we can find the degree of a polynomial. That is the highest power of the variable. Obviously we are talking about a polynomial in only one variable. So now if we talk about, I can take another example, and what will be the degree of this polynomial? If I write the polynomial as 3x plus 7 by x, what is the degree of this polynomial? Can anyone tell me what is the degree of this polynomial?
Sir, no degree.
Sir, 3.
polynomial.
It is
Because it is not a polynomial.
yes, excellent.
Polynomial.
It is not a polynomial. Very good. It is not a polynomial. Excellent. So now we move on to the next definition, what is called a linear polynomial. The next is linear polynomial. Any polynomial of degree 1 is called a linear polynomial. So any polynomial of degree 1 is called a linear polynomial. For example, you can take example 3x plus 7. The degree of this polynomial is equals to 1, hence it is called a linear polynomial. Next is quadratic polynomial. Quadratic polynomial. So quadratic means the power 2. So here we write any polynomial of degree 2 is called a quadratic polynomial. So any polynomial of degree 2 is called a quadratic polynomial. We can take an example 3x square plus 7x plus 2. So the degree is equals to 2. So whenever you find a polynomial whose degree is 2, it is called a quadratic polynomial. Similarly, we can have a cubic polynomial. Cubic polynomial, any polynomial of degree 3. So we write any polynomial of degree 3 is called a cubic polynomial. So you can take an example 3x cube plus 7x plus 2. The degree of this polynomial is 3. So the degree of a cubic polynomial is 3. Obviously, mind it, we are talking about the polynomial in only one variable, and according to the degree, according to the power of the variable, we are defining the different polynomials as linear, quadratic, cubic. Now the next one is constant polynomial. Now what is called a constant polynomial? Constant polynomial. A constant polynomial will be having only the constant term. So a polynomial having one term consisting of a constant is called a constant polynomial. Is called a constant polynomial. Here the degree of the polynomial. What can be the degree of the polynomial for a constant polynomial? Can you tell anyone? Is 0. A constant polynomial consists of only a single term, and that is a term which is also a constant. So you can write, for example, any number 5, 7, -3. So like this, any number which is not having are all constant polynomials. Okay, so we have the different types of polynomials: the linear polynomial, quadratic, then we have cubic, then we have come to know about what is called a constant polynomial. Now hopefully you have understood this. Now moving on to degree of a polynomial will in 2 or more variables. So the next we'll talk about here we had taken only the polynomial having a single variable. Now we'll discuss about degree of a polynomial in 2 or more variables. So what will be the degree of a polynomial in 2 or more variables? Write down: if a polynomial involves 2 or more variables, then the sum of the powers of all the variables, then the sum of the powers of all the variables in each term is taken up, and the highest sum so obtained is the degree of the polynomial in 2 or more variables. So what is called the degree of a polynomial? What is the degree of a polynomial in 2 or more variables? If a polynomial involves 2 or more variables, then the sum of the powers of all the variables in each term is taken up, and the highest sum so obtained is the degree of the polynomial in 2 or more variables. Let us take an example: x cube y square plus x square minus 2x square y to the power 4 plus 2 by 3 x y cube z4. If we talk about this,
Sir, video is not clear.
Video is not clear. Now it is okay.
Yes, sir. Yes, sir.
So degree of a polynomial in two or more variables. If a polynomial involves two or more variables, then the sum of the powers of all the variables in each term is taken up, and the highest sum so obtained is the degree of the polynomial in two or more variables. So we have taken example. The example of the polynomial in two or more variables is here: x cube y square plus x square minus 2x square y to the power 4 plus 2 by 3 x y cube z to the power 4. Now if you look into this, in each term you will find the total number of variables appearing in the polynomial are this x, y and z. Though a few of the terms of this polynomial may not contain the variable, all the variables, but still this is a polynomial having three variables x, y, z. So you just count the total power of all this. What is the sum of x, power of x and y? 3 plus 2, 5. This is 2. This is 2 plus 4, 6. This is 1 plus 3, 4 and 4 plus 4, 8. So the highest power here is coming to 8 after adding the powers of all the variables. And this highest value is the degree of the polynomial. So what will be the degree of this polynomial? Degree will be equals to 8. I repeat, you sum or add the powers of all the variables for a particular term. So if we talk about this first term, we have two variables x and y. Add the powers, 3 plus 2, 5. This is 5. There is only one variable, power is 2. Two variables x and y. So if you add these powers, 2 plus 4, this becomes 6. And three variables x, y, z, and adding the powers, 1 plus 3 plus 4, we get 8. So sum of the totals of the powers, this is 8, the maximum. So the degree of this polynomial in two or more variables is 8. Here we have three variables. Okay, hopefully you have understood. Now the next one is substitution. Substitution. Now what is the meaning of substitution? You already know what is a substitution, but still just write down: in any given expression. In any given expression, the process of replacing or substituting each variable by one of its given values is called substitution. We take an example that will be much clearer to you. Example, we have 3x plus 7 is a linear polynomial. You know why it is called a linear polynomial? Because the highest power of degree is 1. So if we take the value of x, you can take any particular value for x. So if you assign the value for x, suppose it is 3, right? So if x is 3, now what will we do? You will substitute this value of x in this position. We put the value of x as 3, which is called substitution. That means replacing the value or substituting the value of x, and that is equals to 3, and we get a particular value. So that the value of the polynomial is how much? 3x plus 7, that will be 3 multiplied by 3 plus 7, that is 9 plus 7, and that is 16. So the value of the polynomial is 16. So this is called substitution. So in any given expression here we have 3x plus 7 is the expression. The process of replacing or substituting each variable by one of its given values. Here we have only one variable x and the given value is 3. So if you substitute x by 3 and then calculate, then we have the value of the polynomial which is 16 in this particular example. Okay. So this is the fundamental, a little bit of fundamental concepts what we have discussed about, and let us discuss a few questions which are appearing in the first exercise of your book, and then we will proceed further regarding the addition, subtraction, multiplication and division of the algebraic expressions. So before that, let us look into the exercise. If you got the books with you, just turn your first exercise of this particular chapter and we will discuss a few questions on this. First question is, pick out the variables and constants. Pick out the variables and constants. We already know what is called a variable and what is called a constant, so it won't be much difficult for you to find out which is a variable and which is the constant. 5x square y square. Okay. Let us we write here variable, we write here constant, and the expression will be on this side, expression. So let us take the first one, that is 5x square y square. 5x square y square. Here you can see very clearly we are having two variables and those are x and y. So variables x comma y, and what is the constant? Constant is the value 5. Is it clear? We have ab square. The variables are a and b and the constant is 1, because nothing is appearing means 1 is there. Next we can take minus p square g cube, minus p square g power 3. The variables are obviously p and g, and this have got one constant term, that is minus 1. Then we can take 0, means no variable, and only the constant is the term value 0. So hopefully it is clear now. Now we'll second question, to identify the monomials, binomials and trinomials. Is the first question clear to all of you? Any doubt, anyone?
No, sir.
Okay. So moving on to the next question. So we have to pick out the monomials, binomials and trinomials. Monomials, binomials and trinomials. So question number 2. So let us have the first expression here, that is 7a square minus 6b square. 7a square minus 6b square. We know that the terms of an algebraic expression are separated by a plus or a minus operator. So here it is minus. So there are two terms in this expression. So if there are two terms, one is 7a square, one other is minus 6b square, and this is a binomial. So two terms mean binomial. We can take the next one, minus 1. It is only having a constant term, so you can call it a monomial. Next we have minus 7x cube plus 4x square plus 1, plus 4x square plus 1. Three terms. This first term, this is second term, and this is third term, because they are separated by the operator plus. So this is a trinomial. So this way you can find out which is a monomial, which is a binomial, which is a trinomial, and this way according to the number of terms present in the expression, obviously the terms are separated by a plus or minus. Question number 3 we can take. Numeral coefficient. We have to write the numeral coefficient. The number, the constant, that is the numeral coefficient. So number 1, it is minus 3x square y, minus 3x square y, and the numeral coefficient is, let me do it in the tabular form, expression, and this is numeral coefficient. If we talk about the numeral coefficients, the first is minus 3x square y. So we have the variables x, y, and the constant is minus 3. So numeral coefficient is minus 3. Second one is 7xy. The number 7 is the numeral coefficient. Third one is x cube. 1 is the numeral coefficient. And the fourth is minus 8x. So minus 8 is the numeral coefficient. So always remember, you won't be attaching a negative sign to the variable. The negative sign, if it is present in the expression, it will be along with the constant term. Not, for example, minus 8x. The constant will be minus 8, not 8. Okay. So now moving on to the next question. Write the coefficients of we need to find the coefficient of the given. Let us find the coefficient expression, and we have to find the coefficient. So we are given first one, find the coefficient, or write the coefficient of a in 15ab. A in 15ab. So the coefficient of a will be all the factors other than a. So if it is a, then only leaving aside a, we have 15b is the coefficient of a in the expression 15ab. Similarly, number 2, x in minus 8x. What is the coefficient of x? So obviously it is minus 8. Third, what is the coefficient of x in 8x y z square? So leaving aside x, all other factors are the coefficient. So we have 8y z square. So this way you can find the coefficient of a particular variable in the expression given. So you have to leave aside that particular variable, and all other factors will be the coefficient of that particular expression. Now the next one is number 5, to identify the like terms. Identify the like terms, and you know what are like terms, so no need to explain it, and just you can see to this question and you can answer very easily. The first one is, we have a square, then 2b square minus 3a square, 5a square, 6b square, and c square. So you need to group the like terms. So we have the like terms. I am not going into the definition. Once again, you already know what are called like terms. If you have forgotten, you can refer to the notes that you have discussed in the previous class. So here we have the like terms: a square minus 3a square and 5a square. So we have a square minus 3a square and this is 5a square. Anything else? 2b square and 6b square. Also we have 2b square and 6b square. So 1, 2, 3, 4, 5. C square is left alone, so it is only a single term. So basically here we have the like terms a square minus 3a square and 5a square, and other numbers are 2b square and 6b square. These are the two like terms. So let us take another example. Minus 7x square 8yx minus 3xy, then we have 5yx, and then we have 18x square. 18x square. So whether it is yx or xy means the same thing. So we have the like terms as 8yx minus 3xy and 5yx. So if you write 3 into 4 or 4 into 3 means the same thing. Okay, so here it is 8yx, then minus 3xy, and then 5yx. These are the like terms, and we have minus 7x square and 18x square. Minus 7x square and 18x square. These two are also like terms. So this is what is about finding or identifying the like terms. This will be very much helpful in the next part of the discussion, where you will have to add or subtract the algebraic expressions. Now the next is which of the algebraic expressions are polynomials. So we will note down a few polynomials, and we have to identify whether they are polynomials or not. Okay, so the next question is identify number 6, which of the following algebraic expressions, which of the following algebraic expressions are polynomials? We have discussed about polynomials. We have discussed about which expression will be termed or called a polynomial, which not. So again, I am not getting into the discussion of that. You just need to identify whether it is a polynomial or not. So it is expression, and here we will write polynomial. We'll simply write yes or no. Okay. The reason you might be knowing, so I'm not asking you the reason. First one is 4x square minus 7x plus 2. Is this a polynomial? Answer me. Is this a polynomial?
Yes, sir.
Yes. So we'll write
Yes, sir.
y. Second, we'll write root over 2y cube plus root 3y. Is it a polynomial? Yes or no?
Yes.
Yes or no?
Yes, sir.
Only one answer. Yes. And others? Any confusion here? You might be confused with root 2 and root 3. Though you don't need to get confused with root 2 and root 3. Only if you are confused about the square root or the negative powers, that is only for the variables. These numbers, don't worry, these are okay. So this is a polynomial. Okay? So if I am writing, I am taking another example. It will be clear to you. If it is root over 3 into root over t plus root 5t. In this case, it is polynomial or not?
No, sir.
It is not a polynomial because here we have the square root of t, right? So it is not a polynomial. So don't get distracted, don't get panicked, because the thing is you need to stick to the basics. Whatever is being told in the definition, just stick to the basics and try to find out the reason behind. Otherwise it will be no problem for you. Now another question, if I take about y to the power minus 1 by 2 minus 3y plus 7. What about this? Polynomial or not a polynomial? Y to the power minus 1 by 2 minus 3y plus 7. Is it a polynomial? Yes or no?
No, sir. Not a polynomial. No, sir.
This is not a polynomial. The reason is we have the power of the variable as minus 1 by 2. So negative powers is not acceptable in order to define an algebraic expression to be a polynomial. Okay. So now that we have understood a few facts about the fundamental concepts of algebra, in the next discussion, in the next class, we'll be discussing about the operations on algebraic expression, just like the addition of algebraic expression, subtraction of algebraic expression, multiplication, division, and followed by the last thing that you have done in the chapter called fraction, that is the application of the Bodmer's rule, right? That is called the simplification, how we will be going to solve or simplify an algebraic expression. So now, and that I think the Bodmer's rule is very much known to you. So in the next class we will be taking up addition, subtraction, multiplication, division, and the simplification of the algebraic expressions. Today we have to conclude the chapter today because the time is already over. So just go through all this, try to develop the concept, and only way, as I told you, the only way to learn maths is through practice. The more you do practice, the more you will learn. So all the best. Thank you very much. Have a nice day.
Thank you, sir.
Thank you,
Bye,
sir.
sir.
Bye, sir.
Bye bye.